how we're trying site reliability engineering. So I'm going to go off piste slightly. This isn't, I'm making an assumption here, please tell me otherwise, that this isn't that technical an audience. So I'm going to try and keep it more from a product, and I've got a mixed shaded learning. I used to work in e-learning, so I've got to try and cater for different audiences here. So bear with me if I do stumble a bit. Okay, so a bit about me, just to give you some context. This September, I've been in the industry for 21 years. I started out at the age of 16 in a computer shop, just finished my GCSEs, and I used to fix computers. So fixing desktops, and then I did server engineering, I used to work for the NHS, fix servers, and I became a DBA, SQL Server 2000 and SQL Server 7, I think it was. And then I got promoted to being an IT manager in a small SME, in a voluntary sector organization, then an SME. Then I went back to my passion of software engineering. It was a really scary jump. Do I leave behind Microsoft Active Directory and Microsoft Exchange, the things I knew really well, and jump into software engineering? So I did a career change. It was a monumental decision. It was a big decision for me. I did that for a number of years. Then became a lead architect. And then I got demoted back to a DevOps engineer. So I've been at, so prior to me being here, I was just at The Economist. I was just around the corner in John Lewis. And Alex and I used to work together. And the joke I was making earlier, we were pushing the cloud boulder up John Lewis's steep on-premise architect, waterfall hill. So I was hired as lead engineer. On paper, I was the most senior engineer within John Lewis. In reality, it was different. And I gave myself the title, I often change my job titles all the time. I gave myself the title of Cloud Evangelist, and we were bringing Google Cloud into John Lewis. These guys, John Lewis is still going through it. They're not quite admitting it, but they're going through stage 0 of their digital transformation. I'll go into what the different stages mean. My team was spun up in Birmingham. I'm actually from Wolverhampton, but as soon as I get past Watford, my London filter kicks in, so all you can understand me. Our team was the canary deployment for Agile for Digital for John Lewis. So hey, Jujhar, here's his budget, spin up 4 engineers in Birmingham, and can you work on projects in an agile manner, in vertical slice, from design to deployment. And yeah, just the 4 of us, we were banging stuff out in a third of the time. And then the other thing we were trying to do was trying to help everybody else in John Lewis, go through the same journey, right? Lots of Oracle, disgusting, evil stuff going on, trying to move them away from that, trying to move them into cloud and all that kind of stuff. So I got tapped on the shoulder by Mark and asked to spin up another nearshore office in Birmingham again. So it means I don't have to leave my... basically, I got a 4-bedroom house, detached house, for the price of like a London shoebox. So the best of both worlds, right? I'm very proud of this, a Microsoft certified professional in Windows 95. So I'm open to offers of consulting if anyone wants to sort of talk net BIOS over novel NetWare, IPX, that kind of thing. I'm available at discounted rates. Right. So what I want to talk about is The Economist, the challenges we're facing into, how I believe that site reliability engineering is going to solve all the problems. I'll probably skip the practical. If I got some time, I'll do a little example, and then questions, right? Okay, so I just want to set the scene because this is really important to me. Just so you understand my mindset. Software is about people, and I truly believe that, right? We rely on software, and software relies on us. Andrew Schaefer is one of the sort of fathers of DevOps. By the way, is everyone okay with the term DevOps? You want me to just go into that a bit more? Okay, cool. I don't want to make any assumptions. yeah, and this is one of my sayings, software is about people. Get your people right and your software will be right. Okay. And my line manager says, people are hard, and Jujhar, you're the hardest of them all. So Andrew's not here to defend himself. So right, okay. So the challenges we're facing. So here within the, so let me talk about digital transformation, and forgive me if I'm sort of teaching grandma how to suck eggs. I just want to lay a common foundation by what I understand digital transformation to be. But historically, software, because it's got electricity flowing through it and it runs on computers, you give it to IT, right? And IT is not the right place to build software. It's about ITIL, it's about stability, it's about being risk averse. But we want to move very fast, we want innovation, the goals are very different. So for me, a digital transformation is where you come out from under the yoke of IT and you spin up software engineering teams, product teams to deliver software. IT is about configuration and vendors, and digital is about IDEs and cloud and all those things, right? So, so around 3 years ago, Mark, we started the digital transformation. So that's what I call stage 0. We're just starting out. We're starting to say, hey, agile. Hey, software engineers, not Oracle or whatever, ATG or whatever it is you want to buy. So we are here. This is where I believe we are, and my colleagues will disagree with me, and that's fine. We're at stage 1. So done. We're out from under the yoke of IT. By hook or crook, we're here now. Now digital is a thing within the Economist, and we're looking inwards and we're looking outwards, and we're trying to develop software to make our colleagues' lives better, as well as our customers' lives better. So we're developing software, we're getting there, and we've done it by hook or crook. And I use that term. I'm being very honest here. Drains up. So we've got there. It's not an easy thing to do. It's a cultural change more than a technical change, and these things aren't easy. So we've managed it. So give ourselves a pat on the back and give my boss a pat on the back. But yeah, hook or crook. So we've used a lot of contractors, we've used a lot of managed service. Some of the technical leadership hasn't come from the Economist side, and the businesses realize this. So they're saying, "Hey, we'll go to Birmingham because there are amazing software engineers there, and we'll try and get to what I call stage 2, and that's about stability, maturity, process. Kaizen. I love my lean stuff. So about process improvement, and then after that we can accelerate to stage 3, which is nirvana. That's a Sikh and a Buddhist term. They mean the same thing to both of us. And that's innovation. That's where we've become market leaders, and other organizations are following us. Other engineering teams are saying, hey, look, The Economist, they've cracked this. Let's follow them. So this is my plan. This is what I'm pushing for. In 2 years, we want to get to nirvana, right? So, and site reliability engineering is one of the ways I hope to effect this. Right. So, I thought I saw a typo there. Right. So some of the challenges we're facing, more specifically, basically, DevOps is just sysops. And occasionally they'll throw an API, maybe write a couple of lines of bash or something and throw it somewhere in Git. And then they call that DevOps. DevOps to me is you're a software engineer first and a server person second, not a server. Basically, lots of server people are thinking, hey, no one's buying servers anymore. Quick, what should we do? Let's do an AWS certification just so we've got a job in the next 10 years. And that's not quite. DevOps is DevOps, in my mind, right? Not ops, dev. Okay. So DevOps is, and we're changing this, DevOps is seen as a vertical silo, not a horizontal practice. So there's a DevOps team. Hey, we need this thing deploying now, throw it to the DevOps team, rather than it being DevOps is embedded in the mindset of everybody on the team. So, we're changing that, and it's slowly it's working. So my team embed within the projects. And as I go, I'll show you more later. DevOps engineers, our engineers aren't cutting code on the projects. They're not feeling the pain of their peers. So that's another anti-pattern. They need to sort of know what it is to write React, or what it is to write some Java, or what it is to write some Go, or what it is to write some Node. We don't have time to pay down tech debt. It's always moving on to the next feature. The business doesn't feel the pain of tech debt. So what happens is the DevOps team and the rest of the developers are just spinning more and more plates as the technical debt mounts. There's more and more plates because the business still want feature development. They expect the velocity of feature development to continue at the same pace. And again, people are seeing DevOps as a tech problem, not a cultural problem. So it's just a mindset shift, right? This floorboard's really creaky, or I'm really heavy. I won't answer that. Okay, so some more challenges. There are no DevOps people anywhere in the world left. It looks like the Telegraph has hooved them all up. So yeah, they're just like unicorns, and the market's nuts. I have been pinged 3 times today on LinkedIn with offers of jobs, DevOps jobs. That's just today. That's how crazy it is. We've traditionally had an over-reliance on our managed service partners, and we've over-relied on them rather than augment. We've kind of thrown everything over to them, and it's kind of we should meet them halfway. We have some challenges with quality and reliability. Things do break. I'm not going to tell you how much. This makes us look bad. They occasionally break, and occasionally we have quality problems. So, and velocity, then feature development slows down, right, when we're facing into these technical challenges. Hey, we're putting this fire out. Sorry, guys, we can't deliver you this feature. Yeah, and the firefighting is preventing innovation, right? The more fires we fight, the fewer things we innovate on, right? So it's kind of a vicious circle. So, site reliability engineering. So again, 2 key concepts. Again, Andrew, if the systems are down, the software has no value. Right? So you can carry on developing your cool features and have all the beret-wearing, visual graphic designers producing wonderful wireframes of your software and what it's going to look like. But if it doesn't work, it means nothing. Performance is a feature. Stability is a feature. Usability is a feature. The usability thing is less DevOpsy, but performance and stability, they are features. And so with site reliability engineering, this is what we're trying to bring up and shine a light on and make sure that everyone understands that. Right, so site reliability engineering, my friends over at Google. Where are they? They're all around us, Google. Site reliability engineering is what happens when a software engineer is tasked with operations. So you go to a software engineer and you go, here's a server. And the software engineer goes, what's that? You say, that's where your code runs. And so immediately the software engineer will pick it up, sniff it, start looking at it, looking from different angles, plugging the wrong thing in the wrong place. But eventually they'll want to they'll do what software engineers do, right? They'll write code to manage it. So that's what happens when you give software engineers servers, is they come up with site reliability engineering. And another way of thinking of it is, for you programmers out there, if DevOps is an abstract class, then SRE is an implementation. It implements. DevOps is a loose set of principles and practices, and site reliability engineering is a specific implementation of those practices. And this is the key thing. We always remember in site reliability engineering, make tomorrow better than today. Make tomorrow better than today. That's the site reliability engineer's motto. The other thing site reliability engineering does is it leanifies, that's not a word, I made it up, software engineering, but also touches agile, service management, it affects the testers, architects as well, and all their governance and security and other bits. So all of those will start to be affected as well. So it's not just how you deploy things, all these other things start to change as a result. It's a bit of a fait accompli because Okay, I'll gloss over that. You need, for this to work, you need the leadership and the business. So you need your leaders, your managers and line managers and powers that be, and the business to buy in for this to work. It will not work unless everyone has skin in the game. So it's kind of not worth attempting unless you can get this buy-in, this vertical buy-in. Right. Okay, so just very briefly, site reliability engineering. We have these three terms. So I'm just going to go and explain these acronyms. Right. We've got service level objective, and the definition of that is how reliable does one of your services, how reliable does your mobile app, how reliable does your internal API, how reliable does your customer-facing website, how reliable does your B2B website, how reliable do your B2B APIs, how reliable do they have to be to meet the needs and wants of your users, right? A service level indicator, these are the things that we measure that make up the service level objective, and I'll give you some practical examples to sort of flesh that out, right? So, and a service level agreement is, it's like a service level objective, but it's more for all your sort of double-breasted lawyers. And when a service level objective is breached, then a service level agreement normally has a financial penalty on it. It's just an extra layer on top of an SLO. So I tend not to worry about this. I only think in these terms here. If you're more customer-facing, if you're a SaaS provider and that kind of thing, then you probably also think about SLA. Hey, our API was down, our customers couldn't use the project management software, whatever. We're going to give them back 10% of their subscription fee. Right. So service level objectives and service level agreements are defined like this, right? So how reliable, available does a service need to be to meet the needs of its user? The higher the availability, so 100%, I'll talk through this. Okay, I think I've skipped something. When you say a service is available, that doesn't just mean it's working. That means it's working well. It's working in a fast, timely manner. It's responding in the right way. It's returning the right data. Just because it's fast doesn't mean that the data's correct, right? You just can't send any old gobbledygook. So availability also encompasses those things as well. It's not just, hey, the site is on, so we're okay. Pingdom said, site, I can get to it, that's fine. There's more to it than that. It's a multi-dimensional picture. Right, but, so Tom comes to us and says, new editorial system, it can never, ever go down, ever. Otherwise, that's it, you're all fired. So the downtime per month we're allowed is 0 minutes. Now, to make something that reliable, we're going to have to use Azure, we're going to have to use on-premise, we're going to have to use Google. Our code is going to have the quality of Boeing's sort of flight instrumentation. It's going to have to be tested for months and months and in extreme temperatures. So it takes a lot to make something 100%. It's never, ever going to go down. Right? And basically, you can't deploy anything ever. So you do your first deployment, and that's it. After that, you can't deploy anything, right? And the cost, maybe I should have drawn it, but it's logarithmic. As you go in terms of availability across the y-axis and cost, it's a logarithmic scale. So as you approach 100%, it just gets more and more expensive. So, yep, 99, we call this 5 nines. 5 nines, you've got 4 minutes of downtime a month. Sorry, 0.4 minutes of downtime a month. And that's pretty much near enough, 100%. 4 nines is more doable. 4 nines is, okay, I can start to loosen my collar a bit. I can give you 4 nines on your thing. High complexity is still going to be expensive, right? So 4 nines, maybe I'll start to still think multi-cloud, you know, on-premise backups, that kind of thing. 3 nines is like, yeah, it's fine. You want 3 nines, we can give you 3 nines. Just using modern DevOps cloud practices, if you stick with well-architected frameworks, that kind of thing. 3 nines we can give you. It's cheap. It's not that complex, and you've got a lot of flexibility. So when people say 3 nines, great. And 99%, well, that's just like, whatever. Here's some code, throw it on the server, see what happens, right? So, yeah, you can pretty much just do what you want whenever you want. So when you're defining your service level objectives, you always do it with the business, right? It won't work unless the business agrees. So the engineering teams and the business say, you say to the business, how available does this have to be? And if everyone will always say initially, it's got to be available all the time. It can never go down. But you need to explain to them in terms of, well, that's fine, but you're not going to get any new features, and it's going to cost us squillions of pounds. So it's always good to think. So the business has to come up with an agreement, a service level objective that can allow you to deliver and innovate on new features, but also make sure you don't cheese off the customers, right? And the other thing with SLOs is they should be reviewed on a monthly basis or on a regular basis, not as, hey, 3 nines, that's it, it's set in stone. You've got to work with the business. If it turns out that your B2C API, your B2B API, so that big bulk subscribers can't necessarily use it on a Sunday evening, it's not the end of the world. Do you need to really bend over and have triple the amount of servers you need just for something that is only used between Monday to Friday? So the lower you make your SLAs, the easier life will be. And it gives you time to work on the other projects that need SLAs. Right. So for this to work, everyone needs to feel the pain of technical debt. And you can't just keep spinning. Hey, we want this feature. We want it in 2 weeks' time. And so everyone just works like crazy beavers, gets it done, deployed by hook or crook. But they've created a load of technical debt. They've a bit of duct tape and put this together and thrown it together, and it kind of works. But now we need like an engineer half the time, and he or she is sitting there restarting the server every time you see an issue, right? So that's hidden technical debt. And what happens is the engineering team see it, the engineering team feel it, but by the time it goes up the layers through the product manager, through to the business, it gets lost in translation, and they're not feeling that pain. And then they'll come with a whole bunch of the features, and that takes twice as long because you're balancing all this other technical debt, right? And everything else is falling apart underneath, and before you know it, you're just walking in you're just marred in treacle, right? You're not getting anywhere. So for this to work, the pain has to be visible. Everyone has to see you clutching your jaw every time. So the service level agreements, that's why you agree with the business, and the metrics are very visible as well. So those are communicated to the business all the time. Hey, our service level objective was breached this month. And the other thing is you transmit the pain. So you got 2 choices when your service level objectives aren't being met. You can lower the service level objective, right? So I can't give you 4 nines, I can give you 3 nines, right? And everyone in the business might think, well, that's acceptable. Maybe we were a bit too unrealistic with the 4 nines thing. No one's really complaining, so it's fine, right? Or you slow down, and this is why I talk about transmitting the pain up to the product owners, up to the business. Slow down feature development and have the entire team work on fixing the technical debt to bring the service level objective back up. So that might be re-architecting, that thing that little Python script that you write needs to be written properly, need a different database type, or the content must be a different caching, whatever it is. You need to instrument more, so if there are funny things happening and you're not quite sure why the service keeps failing, at 3 p.m. on a Thursday, put more metrics in your system and surface them, so maybe you can spot the trends. Maybe refine your deployment process, so you do green-blue deployments, or canary deployments. Deploy it to do a bit of A/B testing, find out what the issue is, and improve the pull request process. Maybe the way, and I include testing in this, right? The pull request process. So maybe your testing strategy is not right. Maybe a documentation, whatever it is. So the way you transmit this pain back up to the business is you say, hey, look, this service level objective, this big number here on the screen behind me, is not being met. Therefore, customers are being unhappy. We need to work to bring this back up. Therefore, we need to pause on feature development, pause completely or partially, and then everybody on the team, because everyone needs to know, again, DevOps isn't a silo, everyone on the team works to fix that, bring that number back up, and then, okay, next sprint, we're going to carry on with feature development. But that's how you transmit the pain to the business, not just take it on and then keep more and more plates spinning, and then everyone just has a nervous breakdown and nothing gets delivered. Right. Right. Service level indicators are what you are actually measuring, the technical things that you're actually measuring. Well, not just technical, but these can be numbers of users that are happy with the service, numbers of users that are sad. I just picked some random ones. 80% of API calls are returned in under 20 milliseconds. So that's our users are happy, our users of our technical product. Website returns data that's 99% of the time that is accurate. So it's not gobbledygook, there's not weird characters or anything weird. Is the database reliably backed up every day to another site? So if you're banking and you had compliance things, that might be a service level indicator. Are the backups working? Hey, they're not, because we're doing this crazy re-indexing at this time and the backups are failing, right? So bring your backups into SRE mentality. And a key one, are the number of security vulnerabilities in my product that's being regularly scanned, are they 0? Or are there any 0 high level vulnerabilities or threats, right? That indicator, these are all indicators and they make up your service level objective. If any of those are less than what you set them at, then your service level objective that number goes down. So it goes down from 4 nines to 3 nines to 2 nines to whatever, right? So these are the actual things that we're measuring on a technical level to make up that big round number. I'm going to skip on the demo, if that's okay. I was just going to log into CloudWatch and just monitor a MySQL database. The other thing as well is we're using, we've come up with our own naming convention. So we use PagerDuty, and I'm sure you guys use it too. And what we do is we define a service, and the service is Mugstore. So where you buy your Economist mugs from. Mugstore, e-commerce, because there's Mugstore manufacturing. There's different services. Mugstore has several different services that allow us to create, design. So the Mugstore designer for the Mugstore shop. So Mugstore e-commerce, and then the database component of the Mugstore, because there'll be a website component of it, there'll be a mobile app component, there'll be a payments component of the Mugstore. CloudWatch is Amazon monitoring tool, and we check if the connections are high. So the number of MySQL connections, if they're more than 100, throw an alert, our service level, and change the service level objective number is not being met. The disk on the database is too high. You also have a lot of black box testing in SRE. It's a concept they use a lot. So what I was going to demonstrate is I was going to connect to Google Cloud, Kubernetes, and I had a service that connects to our Amazon database. And so I'm checking it from another cloud provider. I'm just checking, is the number of rows in this database more than 100? So it's all very well, okay, the CPU looks okay, the disk looks okay, the database is okay. If the database is full of dodgy trash data, right, that also needs to be checked as well. So getting started, this is what we're doing. Go through your service catalog and pick some low-hanging fruit. Pick a nice, easy vertical slice. You need leadership and product owner buy-in. So if you need that, you're more than welcome to borrow these slides and put it in front of their nose and get them to understand what you're doing, right? You must slow down feature development when the service level objectives aren't being met. Your SLOs need to have teeth. Otherwise, just don't bother doing it. It's not going to work. It's just another fancy framework, and you'll have a whole bunch of acronyms and more complexity, and it won't make a difference. So that's why you need everyone, the business, everyone needs to buy into this. Your SLOs need to have teeth. There needs to be a penalty when SLOs are not being met. Remember, reliability is a feature. If your system's down, software has no value. Your SRE engineers, what used to be called DevOps engineers, need to spend at least 50% of the time actually cutting code with the engineers, right? So if they're on the website writing React code and modules and whatever, React, jQuery, I don't know. Writing iOS, Objective-C. It's not Objective-C anymore, is it? Swift, yeah, sorry. SRE engineers need a lot of mental space in order to figure out how to make tomorrow better than today. So you've got to give them a lot of mental space, and they go away and think, how can I make this deployment is really painful. How can I automate some of this? How can I make this better? How can I improve this better? How can I improve the documentation? So it might not just be like a code thing. It might be the documentation or the communication is bad, and that's why the process is failing. The site reliability engineers need to have that time to think. So that's why I'm saying they only spend 50% of their time on product features, and the other 50% is on how you make tomorrow better than today. All the engineers spend time, when the SLOs are breached, all the engineers on the team spend time making the SLO better. So they should spend 10 to 20% of their time when the SLO is breached actually cutting. And all of a sudden, everyone starts taking care about, they'll write more unit tests, they'll think about more edge cases, they won't just bundle their software up in a port, they'll test their software more, they'll test the performance, because everyone's skin is in the game and everyone is collectively feeling the pain, not just those poor guys stuck up in Birmingham clutching their jaws and no one's seeing them, right? Yep, automate all the things. And I just want to finish with this. This is from Tanya. She's a site reliability engineer in New York for Google. And I just think it really encapsulates the SRE mentality, SRE engineering mentality. Thank you for pointing out this gap. And then I'm going to go and make it so nobody can break this software in the same way again. Okay, so so if you want to get started with this book is free, the Site Reliability Engineering, online anyway. So go there. Google SRE blog is also very good as well. Liz Fong, she's one of the key SRE engineers. She's fantastic. I've created a YouTube SRE playlist as well, so it's got loads of good curated SRE videos on there, so that's good. And my Twitter, Stack Overflow, everything handle is JujharS13. Thank you very much.